Right, good day everybody, and welcome back to Corona Matric Maths. So, we were doing the other day on that ghastly lesson, finding the derivative of a function from first principles. Well, just to recall quickly, the first idea is how do we find average gradient of a function between 2 points. So remember, what is average gradient? It's the gradient of the straight line joining 2 points on the curve. So if I have that point over here and that point over there, and I want the average gradient, what's the process that I go through? Well, first of all, the points, you'll have to normally find the y values. So if this is curve f and that's point x, and this y coordinate that goes with it would be f of x. And remember, h is the distance that you move across between 2 points. If h is positive, you're going that way. If h is negative, you're going that way. And then this point over here, if you start at x and you go h across, the x coordinate here will be x plus h, and then the y coordinate will be f applied to that x coordinate, which in this case will be f of x plus h. Right, so those are 2 points. Then to find the average gradient between any 2 points on the curve, it will be equal to change of y over change of x between those 2 points. So in this case, it would be f of x plus h minus f of x over the change, the difference between the x coordinates, which will be x plus h minus x. And if I simplify that, I end up with my average gradient formula, which is that. So there is your average gradient formula, which is the gradient of the straight line joining 2 points. Now, what I want to get is the gradient of the tangent at this point. What we start talking about is the gradient at the point. What does that mean? Is that the gaps between the 2 points have become so small that essentially there's no gap. But there actually is. Okay. And we're actually talking about, we're not talking about the gradient at a point. What we're talking about is the gradient of the tangent at that point. In other words, how the curve is changing at that instant. What's the instantaneous rate of change there? Okay. And so to find a formula for the gradient at this point over here, in other words, the gradient of that tangent, what we simply do is we make the gap infinitely small. Okay, and how do we write that mathematically? Well, we say make the gap infinitely small is go find the limit at h tends to naught of what? Well, of the gradient between 2 points, okay, which is going to be the limit as h tends to naught of f of x plus h minus f of x over h. And that, guys, is your formula. If only I use this when I'm asked to find the gradient from first principles or the derivative from first principles. So all of these things mean the same thing. What's the gradient at this point? What's the instantaneous rate of change at that point? And what's the derivative of f of x at that point? In other words, what is f dashed x? Okay, so f dashed x, that is your formula which is given to you on the formula sheet, and that we use it when we're asked to find the derivative from first principles. Okay, so whenever you're asked to go find the derivative from first principles, this is the formula that you're going to use. Right. Now remember, when you find this thing called the derivative function, okay, what it simply is, it's an equation, or it's a function. And if you sub an x value into that function, what do you get? You get the gradient at that point on a curve. So every single function has a derivative function that goes with it. If you sub into the key idea is if you sub into the original value, what do you get? You get a y value, original function, sorry, you get a y coordinate at that point. If you sub into a derivative function, you get that gradient at that point. Okay, so remember, we find f dashed x, which is the derivative of the function of f. If we're using first principles, is what will be asked. If we then sub an x value into the derivative equation, it gives you the gradient of the curve at that point. So, in other words, if g of x is equal to 3x squared minus 2, okay, then we can prove that the derivative equation of this particular function g will be 6x. Okay? So if I sub an x value into this, what do I get? Gradient at that point. If I sub an x value into the original equation, what do I get? I get the y coordinate. So hence, using this information above, go find the gradient of g at x is equal to negative 2, x is equal to 0, and x is equal to 3. Right, go give that a go, then come have a look. Right, so the answers, well, if I want the gradient at x is equal to -2, what am I finding? I'm finding, go to x is equal to -2. If x is -2, the y value, just by the way, is 4, 12 minus 2 is 10. So if I take that point over there, okay, that would be the point -2. I sub into the original, I get the y value, which would be 10, but I'm not asked for that. I'm asked to find the gradient at this point. And it looks like it's going to be a pretty steep positive gradient. Okay, but how do I find the actual gradient of this tangent? Okay, I sub into the derivative equation. So the gradient at x is equal to -2, how we write the gradient is the gradient is equal to g dashed of -2. Okay? Which means I've got a derivative equation, which is g dashed of x is equal to 6x, and I replace x with -2. So I get 6 times -2, which is -12. Sorry, did I say this was positive? This is a very negative gradient. So what you've worked out, it's going left to right down at this point on the curve. Okay, sorry about that. This point on the curve, you can see the function is decreasing. It's going left to right down. It's pretty steep at that point. So what we've worked out is the gradient, which we said was equal to g dash of -2, is going to be equal to -12. The gradient at that point, okay, is -12. So in other words, if this was velocity displacement, time displacement graph, then the velocity here would be -12 meters per second. Right, the next question said, go find the gradient at x is equal to 0. Well, what am I finding? Well, I'm finding that gradient of that tangent over there. And you can see over here, on this part of the curve, in green here, if you sub into your derivative equation, you should always get negative answers, because your gradient is negative. In this red part of the curve, if you sub into your derivative equation, you should get positive answers, because the curve is going left to right, up. Any tangent will be going left to right, up. Whereas here, any tangent was going left to right, down. But over here, at the turning point, so the gradient should be equal to 0, because I'm going from a negative gradient, okay, then it becomes 0. Okay, if you're going downhill, you've got to go downhill. Before you can go uphill, you've got to go flat. So this is the flat part of the curve. And in other words, we expect an answer of the gradient is equal to 0. Okay, and then it goes, the gradients will become positive. So all your derivative values on the red part of the curve will be positive. All your derivative values on the green part of the curve will be negative. And at this point over here, we should get derivative values of 0. But let's just check. Well, we know we can find the gradient by subbing into the derivative equation. So the gradient is going to be equal to g dashed of 0. Okay, g dashed of x is equal to 6x. So g dashed of 0 will be equal to 6 times 0, which is 0, which is what we expected. Okay, at this point over here, the gradient is equal to 0. What do we expect for x is equal to 3? Okay, well, when x is equal to 3, just by the way, the y value, remember if you want a y value, sub into the original equation, the y value would be 3 squared, which is 9, times 3, which is 27, minus 2, which is 25. So it's way up here somewhere. So you'd have a point, the point that we're looking at is the point 325. But we're not asked to find the y value, we're asked to find the gradient at this point. And you can see it's going to be very steep. And we expect the gradient to be positive. Okay, it's going left to right up. So if you're asked to find the gradient of the tangent at x is equal to 3, or the instantaneous rate of change at x is equal to 3, or the derivative at x is equal to 3, well, we simply sub into the derivative equation. So m would be equal to g dashed of 3. G dashed of x is 6x, so it'll be 6 times 3, which is 18. So I worked out the gradient at that point over there is 18. Okay. All right. Let's have a little pause. A little pause. Good day and welcome back. Alright, so I want you to try this example. Okay, do it by yourself first and then come watch the solutions. So the question is, given f of x is equal to negative x squared plus 4, determine f dash of x from first principles. Okay, hence find first of all the gradient of f at x is equal to negative 1. Number 2, the gradient of the tangent to f at x is equal to 0. And number 3, the instantaneous rate of change of f at x is equal to 2. Okay. Third question, explain graphically what f of 5 means. and what f dash of 5 means in terms of graphs. Right, okay, give that a go. Okay, so hopefully you've tried that and here are the solutions. So first of all, determine f dash x from first principles. Well, as soon as you're asked to do that, as soon as you see the word first principles, sometimes they say to determine f dash of x from the definition. Okay, as soon as you see that, you're going to simply write, go to your formula sheet and say f dash x is equal to, make the gap infinitely small, changing x infinitely small of the average gradient. Right, so immediately write that formula down. Now, what does f of x plus h mean? Okay, f of x plus h means go to equation f, just like if I said to you f of x is negative x squared plus 4, and I said to you what's f of 2? F of 2 means wherever you see an x, replace it with a 2, so it'll be negative 2 squared plus 4, which is whatever it is. Okay, so when they say to you, go find f of x plus h, what do they mean? They mean go to equation f, and wherever you see an x, change it into x plus h. So in this case, we're working with the equation f of x is equal to negative x squared plus 4, and we're trying to find, by using first principles, the derivative of this function. What is that? That's an equation, and if I sub into it, I get the gradient at the front. So, f dash x is going to be equal to, you've got to write this notation down every single time it comes after the equal sign. You can only get rid of this notation once I've replaced h with 0. Okay, so I'm going to get limit as h tends to 0. F of x plus h is going to be equal to, well, I go to the equation, wherever I see an x, I replace it with x plus h. So it's going to be negative, instead of the x, I'm going to have x plus h. Okay, so it's negative x plus h squared, and I've still got that 4, okay, plus 4. So this over here, that whole thing, negative x plus h squared plus 4 is f of x plus h. I've gone to equation f and I've replaced every x with an x plus h. Then what I've got to do is I've got to minus the whole of f of x. So I'm going to minus the whole of f of x. In other words, I'm minusing minus x squared plus 4. That's f of x over there. That is f of x plus h over there. So it's f of x plus h minus the whole of f of x. All over h. Now what should happen, always in these questions, what should happen is every term without an h should disappear. If it doesn't, you've made a mistake. Okay, what should happen when you're doing a first principles question is every term without an h should disappear, because what you've got to do in order to find the limit, the h's at the top must cancel with the h's at the bottom. You've got to take out a common factor of h from the top each. So I get the limit of h tends to 0. Okay, if I simplify, I get x squared times y negative is negative x squared. Square that out, I get 2xh times y negative is negative 2xh. H squared times y negative is negative h squared. Okay. And if I distribute this negative over here, I get positive x squared minus 4 all over h. So I end up with the limit as h tends to 0. Anything without an h disappears. So negative x squared plus x squared disappears. I've made a mistake because I left out over here this 4 over here. And that's how your check can help you. Straight away I realized there should be plus 4 over here. That over there is that over there. I left out that 4. Okay, but I knew that I made a mistake because I know that everything without an h should disappear. Okay, so negative x squared plus x squared disappears. 4 minus 4 disappears. And I'm left in the numerator with negative 2xh minus h squared all over h. Okay, the next thing that should happen, everything without an h should disappear. You should take out h as a, if I sub in the limit value now, what do I get? I get naught over naught. Remember, a naught over naught situation means there's more work to be done. Normally, you've got to factorize. Okay, so then you're going to take out h as a common factor. So So I get the limit of h tends to 0. I take out h as a common factor, I'm left with negative 2x minus h. Notice I've still got this notation here, because I still haven't replaced h with a 0, because I can't, because I get 0 over 0, all over h. But now, you can cancel out your h's. Okay, the common factor of h cancels with that. And now, I can replace h with 0. So I can then drop this notation. So I get negative 2x times 0 minus 0. I've replaced every h with a 0. Okay, and I end up with an answer of, I've been a complete dumbass, apologies, that when I factorize the h, I should get negative 2x minus h, apologies. Okay, and now I can replace h with 0, and I get negative 2x minus, I replace that h with 0, and once I've replaced h with 0, I can drop that notation. So I end up with an answer of negative 2x. So what have you worked out? Okay, you worked out that if f of x is equal to negative x squared plus 4, the derivative function for this curve, which we write as f dash of x, will be equal to negative 2x. Now if I sub an x value into that, what do I get? I get the gradient at that point, the gradient of the tangent at that point, the instantaneous rate of change at that point. They're all saying the same thing. Okay, so those are my two equations over there. So a reminder, when you're doing sums from first principles, what should happen? Every term without an h should disappear. You should be able to take out an h as a common factor. Then you cancel the h, and then you sub in h is equal to 0, and your solution is your derivative function. Right, so the next part, so we worked out that in this particular question, if f of x is equal to negative x squared plus 4, okay, then we went and found out the derivative equation for that function is negative 2x. Right, so then the next question said, find the gradient of f at x is equal to negative 1. Well, to find the gradient at a point, okay, what I simply have to do, I have to sub into the x value into the derivative equation. So the gradient at x is equal to negative 1 is going to be f dashed of negative 1. That's the notation we use, which means go to the derivative equation and replace the x with negative 1. So it's going to be negative 2 times negative 1, which is equal to 2. Okay. In question 2, it says find the gradient of a tangent to f at x is equal to 0. Well, the gradient of a tangent is the same thing as the gradient at that point, just different language. So to find the gradient at x of the tangent at x is equal to 0, we're simply finding f dashed of 0, which means go to the derivative equation, replace x with 0, and I get negative 2 times 0, which is equal to 0. Right? Equation 3 says go find the instantaneous rate of change of f at x is equal to 2. Well, once again, it's asking you the same thing as these things. All of these things are the same thing. Okay, gradient at a point, gradient at a tangent, instantaneous rate of change. So the instantaneous rate of change at x is equal to 2 will be f dash of 2. I go to the derivative equation, replace x with 2, and I get negative 4. Okay. So what's going on in terms of a curve, just to make sure you understand? Well, I've got the parabola, negative x squared plus 4, which looks like that. Okay, it goes through 2, minus 2, and 4. First question said, what is the gradient at x is equal to negative 1? Well, when x is equal to negative 1, what you worked out that if I drew a tangent at that point, okay, you can see it's going left to right up. So the gradient here was going to be equal to 2. So you worked out when x is equal to negative 1, the curve is increasing at a rate of 2. Okay, the next question that we did, what's the gradient at x is equal to 0? This question over here. Well, that question over there has got to do with this here. Here is when x is equal to 0. That's your turning point. So your gradient is equal to 0. So that's that bit over there. And then last of all, okay, the gradient at x is equal to 2. Okay, well when x is equal to 2, okay, I'm over here, I'm actually at the x-intercept. The y value is 0, but the gradient at this point, we can see the gradients go from positive to 0 to negative. So the gradient at x is equal to 2. That's what we worked out over here. And we worked out the gradient was equal to negative 4. Right, the next question says, explain graphically. Okay, by the way, you don't have to do that unless explicitly asked. Okay, this was the answers to the question, full stop. Okay, then it says, what is f of 5? Well, f of 5 simply means the y coordinate or the function value, okay, the y coordinate at x is equal to 5 on f. You must know this. But if you see f of 5, what are we talking about? The y coordinate at x is equal to 5. Okay, the y coordinate at x is equal to 5 on curve f, so it would be somewhere down here. To work it out, they didn't ask you to, but it's sub into here, and you get negative 25 plus 4, which is negative 21. So f of 5, in fact, is equal to negative 21, but that wasn't the question. The question was, what does this mean graphically? It means the y coordinate at x is equal to 5 on f. And what does f dash of 5 mean graphically? Well, f dash of 5 means the gradient of f at x is equal to 5. You've got to know that notation, what that means. That means the gradient of the tangent to f at x is equal to 5, or the instantaneous rate of change there. Okay. Alright, the next question, example 3, is you're told g of x is equal to 5x plus 1. The question says, go find g dash of x from first principles. Right, give it a go, and then come back and look at the solution. Right, so any question which is find the derivative from first principles, start off by writing down the formula, and this time it's in terms of g, not in terms of h, so it'll be equal to g of x plus h, what's your notation, minus g of x over h. Okay? Right, then what does g of x plus h mean? It means go to equation g, and whenever you see an x, replace that x with x plus h. Remember, you've got to write down this notation every single line until you've got rid of the h. So it's equal to the limit as h tends to 0. We'll penalize you if you don't, by the way. Okay. Of g of x plus h means go to there, so I go to g and I replace x with x plus h. Don't forget you still got that 1. So that over there is g of x plus h. Right. Then you have to take away the whole of g of x. So you're going to minus the whole of g of x. And g of x is 5x plus 1. So there is g of x plus h minus g of x, and it's all over h. Now we simplify it, and what should happen? Anything without an h in should disappear. Okay, but let's just 5x plus 5h plus 1 minus 5x minus 1 all over h. And if we simplify that, we get the limit of h tends to 0. Well, 5x minus 5x, voila, disappears. 1 minus 1, voila, disappears. And I'm left with 5h over h, okay, which is equal to the limit of h tends to 0 of 5. And if I think about it, what's that answer going to be? We talked about it the other day, the limit of a constant is the constant. So I get an answer of 5. So what have we worked out? That if g of x is equal to 5x plus 1, then g dash of x will be equal to 5. Well, what's going on graphically? It should make sense to you. Okay, well, you've got a straight, g of x is 5x plus 1 is a straight line graph. And you know from grade 1 that the gradient is a coefficient of x, so the gradient of this line is equal to 5. Okay, no matter where you are. Okay, so g dash of x is equal to 5. If I said to you what's the gradient at x is equal to 0, then g dash of 0 would be 5. G dash of 3 would be 5. G dash of 1,000,000 would be 5. Okay, so that should make sense to you. If you've got a straight line graph, the gradient is the constant. To prove it, that's how you prove it using first principles. Righty, next example. If h of x is equal to 7, determine h dash of x from first principles. So any first principles question, okay, or it's a bit confusing if I use h of x. Let's use p of x. Okay, otherwise there's going to be too many h's floating around. So p of x is equal to 7, determine p dash of x from first principle. Well, in this case, your formula is p dash of x is equal to the limit as h tends to 0 of p of x plus h minus p of x all over h. Now, what does p of x plus h means? Okay, it means go to that equation over there, okay, and where you see an x, replace with x plus h, but there's no x here. So p of x plus h, okay, is equal to 7. And think about it, what is the function p of x? The function p of x is equal to 7 is a horizontal line, where everywhere the y coordinates are 7. So it doesn't matter what the x coordinate. If the x coordinate is x plus h, the y coordinate is going to be 7. P of x plus h means the y coordinates. So the y coordinates here would be, so the limit as h tends to 0, or p of x plus h is 7. And any y coordinate, no matter what the x coordinate, must be 7. So I get 7 minus 7. So is equal to the limit of h tends to 0 of 7 minus 7 all over h. Okay, which is equal to the limit of h tends to 0, okay, of 0 over h, okay, and 0 divided by anything, okay, h cannot be equal to 0, okay, because of the gap in the curve, okay, and so it's going to be the limit of h tends to 0 of 0, okay, it's not really the 0 over 0, okay, h can't be 0, that's quite important in order to do that, okay, because h is your gap in the curve. And by definition, h can't be 0, otherwise we can't find a gradient. It becomes infinitely small, but it's not 0. So the limit of h tends to 0 of 0 is 0. So what have you worked out? That if p of x is equal to 7, then p dash of x is 0. What's that telling you? Well, it's telling you that no matter what the x value is, the gradient is going to be 0, which is what we expect. Okay. Unusual question, doubt should be asked it, but so I'm sure you're getting sick of this. Okay, but last example. F of x is equal to negative 2 over x. Determine f dash x from first principles. Remember, you're going to start it like that. Give it a go. See if you can try it by yourself first. Right. So, first of all, what does f of x plus h mean? It means go to equation f, and wherever you set x, turn that x into x plus h. So we're going to have the limit as h tends to 0. You've got to write that notation, don't forget. So f of x plus h will be minus 2. Replace the x with x plus h. So that over there is f of x plus h, negative 2 over x plus h. Then you've got a minus the whole of f of x, so it's going to be minus, you don't even really need a bracket here because there's only one term. So it's going to be minus 2 over x and all over h. Well, over here, okay, you're going to have to now, what I'm going to do, when I get a layered fraction like this, instead of having this divide line over here, I'm rather going to write a divide sign. So instead of all over h, I'm going to divide it by h. If you want to write it as h over 1. Okay, with this bit over here, I'm going to go get a common denominator. Okay, so what's the common denominator there? Well, it's x times x plus h. Share it. Quite. X times x plus h. What do I times the bottom by? I times the bottom by x, and I times the top by x. So it's going to be minus 2x. And I times that by x, and I times that by x. Here, what did I times the bottom by? X plus h. So I've got to times the top by x plus h. So I end up with that. If I neaten that up, I get, don't times the bottom out. Okay. I get the limit of h tends to 0. Okay. And let me just check this. I'm being a bit insecure. Okay, minus 2x plus h over x plus h over x plus h divided by h. Okay. When I divide by h, it's going to become times by 1 over h. Okay, that's my mistake. Okay. There's f of x plus h, we've got minus f of x, but f of x was minus 2 over x. Okay, so when I simplify it, okay, that's going to become a plus, because it's f of x plus h minus the whole of f of x, but f of x is minus 2 over x. Okay, and so this will be a minus, and the minus makes a plus. How did I know I've made a mistake? Once again, I know that anything without an h should disappear. Minus 2x plus 2x should be 0. So always use it as a check. If a term doesn't have an h in, it should disappear. So at the top over here, we're going to have minus 2x plus 2x disappears, and I'm left with 2h, okay, over x plus h, and I'm dividing by 1 over h is the same thing as timesing by 1 over h. Okay, now what happens? Well, now that h and that h can cross cancel, and I'm left with the limit as h tends to 0 of 1 over x plus h. And now I can replace the h with 0. So I get the limit as h tends to 0 of 1 over x. Replace the h with 0, so I get 1 over x plus 0. So I can drop the notation, remember. As soon as I replace h with 0, I can drop that notation. Okay, and I end up with 1 over x times x is 1 over x squared. Okay, and that, guys, is your answer. So in other words, we've worked out that if f of x is equal to negative 2 over x, then f of x is going to be, f dash of x is going to be equal to 1 over x squared. Right, just to show you, because I'm sure you're dying to know what you worked out. In the last question, where f of x is equal to negative 2 over x, hopefully you know that's our hyperbola. It looks like that. It's an increasing hyperbola. We worked out that the derivative equation was 1 over x squared. Okay? So, graphically, if I went and found f of 1, you really need to be comfortable with this notation. F of 1 means the y coordinate when x is 1. You'd sub into that equation. In black here, you'd get negative 2. So that means that when x is 1, the y coordinate that goes with it is negative 2. However, your derivative equation is 1 over x squared. So if you went and subbed in x is equal to 1 into that equation, you get 1 over 1 squared, which is 1. And what is f dash of 1? It's the gradient of the tangent when x is equal to 1. Okay, which if you sub it in, you can see you get an answer of 1, which makes sense because the graph is increasing there. Right, I'd like you to go to now exercise 6.3 from your textbook on page 10 and 20. I'll put the memo up on WhatsApp and on Google Classroom. In fact, it's on Google Classroom already. Okay, that, guys, is the end of your new work for your test. Okay, please check, which is on Tuesday, Google Classroom for your test details. If you've done this lesson today, then tomorrow during maths, okay, you can simply revise for your test. Good luck! Hope you're having fun. Okay, may the force be with all of you and stay safe. Farewell.